Everybody, in the last two classes we discussed multiplexer, and in today's class we shall look at demultiplexer, which is also uttered together with decoder, though functionally they are different, but the circuit for each of these is essentially same. So, these are the topics that we shall cover, and to begin, demultiplexer, the function of it is just opposite to multiplexer. So, in case of multiplexer, if you remember what we had seen, that it steers one of the many inputs to the output. Okay. So, this is, we may consider this is a communication channel which is shared by the inputs whenever they feel like, depending on the control input, one of the data input is getting access to the transmission channel. Now, when it comes to the receiver side, say this is the receiver, and this is to be connected to multiple recipients, then there will be a control input to steer it to that input data to one of those recipients. So, this is just the opposite of multiplexing operation. Now, multiplexing was many to one, here it is one to many. So, this is the multiplexing operation that we have to functionally understand the function of it and realize the circuit. So, if it is a 1 to 2 demultiplexer, that means one input and two output. Okay. How do you do it? The circuit is similar to what we had done in the case of multiplexer. The similar logic we have to adopt. So, in this case, this is the select input. So, when select input is low, okay, we consider that D will be steered towards Y naught, the output Y naught, and when so at that time what is happening to Y1? If this is low, this is always at 0, and Y naught, because of this is 0, that is 1, so 1, and D, so whatever is the value of D goes to the Y. So, whenever D changes from 0 to 1, Y will also change from 0 to 1 and vice versa. Okay. So, in the case of S being 1, what happens? So, this becomes 0 and gets, so this will be held at 0, and this is 1. So, Y1 will get the D, right. So, whenever D changes from 1 to 0, Y changes from 1 to 0, and also when D changes from 0 to 1, Y1 will also change from 0 to 1. Okay. So, this is what we understand as the basic circuit. If it is a 1 to 4 demultiplexer, so we shall have, similar to what we had done, we had seen in case of multiplexer design, we shall have two control input S1 and S0, and amongst them they will be generating S1 prime S0 prime, S1 prime S0, S1 prime S1 and S0 prime and S1 S0. These four combinations using appropriate number of NOT gates that will be generated, and they will be connected to the corresponding AND gates. Okay. So, there will be 4 such AND gates with three input similar to what we had seen in case of multiplexer. So, this is the basic circuit, and again when we work with it similar to multiplexer, we shall be using a block diagram to designate a demultiplexer. So, if it is a 1 to 2 demultiplexer, this is the block diagram. So, S0 is the select input, data is going to Y0 when S0 is 0, and Y1 when it is going to when S0 is 1. Okay. This is clear. So, we extend it to 1 to 4 demultiplexer. So, there will be then two data select inputs S1 and S0. So, when they are 0 0, data is going to Y0, 0 1 going to Y1, 1 0 Y2 and Y 1 1 Y3. Okay. So, what will be the corresponding so 3 input AND gates? We have the output of the 3 input AND gates. How will we write? So, we shall write it in this manner. Y0 will be S1 prime S0 prime ANDed with D. Okay. And similarly for others. And when this is 0 0, S1 and S0 are 0 0, what is happening? Y0 is equal to 1 1, D is equal to D, and all rest of the cases these are 0, all 3 are 0. So, output is change, Y naught output is only changing according to D. Okay. So, if you have got a different combination of the select input, so we shall have Y1 or Y2 or Y3 taking the value of the other outputs remaining 0. Okay. So, this can be written in the form of a truth table as has been shown here. So, we now look into one practical implementation of demultiplexer. This is similar to what we had seen in case of 4-to-1 multiplexer. So, IC 74155 is a dual 1-to-4 demultiplexer. So, if we look at this circuit, we can see that the select line is common. So, this is the select line which is common, and this is one 1-to-4 demultiplexer, and this is another 1-to-4 demultiplexer, right. So, this is we can observe, and for this we can see there is a strobe, separate strobe, and this is another separate strobe that is present, and separate data that are present. There is one difference over here, this data over here has got an inverter, this data over here does not have an inverter. Okay. So, this is we take note of, and because of which what we see, the output over here can be written if you combine the logic circuit, these inputs and the corresponding output. So, we can write 1 Y naught, this is the output over here, as B prime A prime. You can see this connection going over here, this is B prime and this is A prime. Okay. So, this is we write as G1. So, this is G1 prime because of the presence of the inverter, and 1 C. Okay. So, this is 1 C that is there because of the 2 inverter that is present. Here is one inverter, another inverter over there, and finally, the whole thing after this AND gate. Earlier there was only AND gate at the output. Here we see after AND gate there is an inverter. So, whole thing is inverted. Okay. So, this is the equation that we get. So, this is for the first case, right, where we have taken this example with B and A as low, and rest of the cases will be B A prime and B prime A, the other cases that will be there. Okay. So, this will be one Y1 will be B prime A and so on and so forth, right. Next one will be B A prime and last one will be B A, right. Okay. So, now how then the truth table will map out? So, we see that when the strobe is at high. So, strobe this is at high, this is the value over here. So, when the strobe is at high, so that will make this output, this particular output is high, means this is 0. So, this is a product term. So, 0 prime is 1, that is high. So, irrespective of the presence of the other value, when strobe is high, all the outputs are high. This is what we can see, clear. And what we see other than that, for normal operation, so this strobe should be low, this should be low. Okay. Now, if we consider this 1C, the input, right, if this input is here low, right. So, this is the case that we are talking about, right. So, again the output will be high for all the cases, right. And what does it what is its significance, we shall see later. And when this is high, this is low and this is low and this is selected, B prime, A prime, both are low. So, this is the case, the example that we are showing here. So, what will happen at that time? The output is becoming low. Now, in this case, if C1 changes from H to L, what will happen? The 1 Y naught will change from low to high, right. So, this output is following the input, but just a inverted manner. Okay. So, output is a inverted version of it. Do you see this particular thing happening, right? So, similarly for every other cases, you will see that when this is selected as low and high, right, that is B is low and A is high. So, please correct this one, right, B is low and A is high, right. then at that time when C1 is high, the 1y1 is getting the low. So at that time if you make C1 low, so if you make this C1 low, so this will go to high, we will follow this one over here. So it is just following the input 1y1 for this particular case, right. 1y1 is following the input, but just a inverted version of it. Is it clear? So similarly for the other inputs for other combinations. So this is what we see for the first set of 1 to 4 demultiplexer. See, the output is inverted in respect to the input. And for this one, what we see? There is no such inversion present. So output is just following the input. See, if you are here, it is C2 is low, right? And then the output is also low. If it becomes high, then the output will become high. Okay. So this is just exactly following the output the same way. Is it clear? Fine. So now we look at another example. Earlier we had seen 1 to 4 demultiplexer. So if we look at 1 to 16 demultiplexer, this is IC 74154. Okay. So in this case also we have got a strobe input, right. So this then the basic equation following the same bank of AND gates at the output, right, and there is a, you can see this is the basic circuit. So these are the select inputs, right, and the output will be, you see the data is inverted here and output is also inverted here. So basically then output will be following the input. So whenever input goes low, output will go low, and whenever input goes high, output will go high, corresponding output will go high depending on the select inputs, right. So that is what you can see here, and of course similar to previous case, this will work properly when the strobe is low. So this strobe is low. If strobe is high, irrespective of the selection input or the data input, all the outputs are high. Okay. So when strobe is low, so if the data is low, right, and if selection is LL, that means ABCD is, the first one is getting selected over here, all the inputs are low. So then corresponding Y0 is becoming low, rest all are high. And if ABCD is 0, 0, 0, 1, LL, LH, low, 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 high, then Y1 is low and all rest are high. Okay. So this is the way, the similar thing what we had seen before. 1 to 16 multiplexer also follows the same philosophy, and we can understand how it works. Now, if we make strobe is equal to 0, right, strobe is equal to 0 and A is equal to 0. So strobe is equal to 0 and A is equal to 0. What will happen? What essentially you are looking at, we are looking at only this part of the truth table, right. Now depending on the select inputs, that is BCD, that is present, because this is always low, right. So data will go, okay, this input data will go either to Y0 or Y1 or Y2 or Y3 or finally to Y7. So essentially it is a 1 to 8 demultiplexer. So from a higher order we can always get a lower order demultiplexer by making appropriate choice of the selection input, how you place values to the input side. If we had made A is equal to 1 instead, right, then we would have looked at this block, right. So depending on the BCD, the output would have been steered to Y8 to Y15. Okay. So this is the understanding we carry from this particular discussion. So then how to get higher order from lower order demultiplexer? Again the philosophy is similar to what we had for the case of multiplexer, right, getting higher order multiplexer from the lower order multiplexer. So here is an example where we see 1 to 4 demultiplexer we get from, how to get from 1 to 2 demultiplexer. Okay. So there are two select lines, S1 and S0, right. So depending on S1, so if it is 0, so D will be steered in this direction, right. So data is going in this direction, and if S0 is also 0, So data will go to this direction, right. So when S1 and S0 are 0 0, so D is connected to Y0, D is steered towards Y0. If S1 is 1 and S0 is 0, what will happen in that case? So S1 is 1, so D will be steered in this direction, and S0 is 0, so that means it will be going in this direction, so Y2 will get selected. Okay. So we can understand that using 3 1 to 2 demultiplexer, we can get a 1 1 to 4 demultiplexer, right. So similar thing can happen for 1 to 8 demultiplexer if we want to get using lower order. So we have got 1 to 4 demultiplexer here and another 1 to 4 demultiplexer at the in the cascaded final stage, second stage, and before that a 1 to 2 demultiplexer, right. So if we take S2, S1 and S0 as say 1 0 1, just an example, then what will happen? So S2 is 1, so D is going in this direction, right. So it is coming over here, then 0 1. So S1 and S0 is 0 1, so it will go here, right. So D will be connected to Y5. That means D is getting steered towards Y5. Is it clear? Right. So this is how we can get it. And if we have in the store only say, conceptually that only 1 to 4 demultiplexer is present. Okay. So then this block needs to be realized by 1 to 4 demultiplexer, because 1 to 2 demultiplexer is not available with you. So this can be realized by a 1 to 4 demultiplexer simply by converting a 1 to 4 demultiplexer to a 1 to 2 demultiplexer. One method we had seen before, that one of the input we are making low or high. So this is another example where both the inputs we are making common and connecting it to S2, right. So if S2 is 0, so it is going here. If S2 is 1, it is going to 1 1, that is the output. So F0 and F1 will be connected from 1 to 4 demultiplexer, 0 0 output and 1 1 output. Okay. And finally, this 1 to 4 demultiplexer, the one that we have seen, we see here, can be realized by 3 1 to 2 demultiplexer, the way we had done it before. And similarly, this one also we can realize in that manner. Okay. So this 1 to 8 demultiplexer can be obtained using only 1 to 2 demultiplexer by here 1 to 2 demultiplexer, and this here 3 1 to 2 demultiplexer, and here another 3 1 to 2 demultiplexer. So 3 plus 3 plus 1, 7 1 to 2 demultiplexer can obtain it by cascading. Okay. This is similar to what we had seen, just the direction is opposite. There we had gone from multiple more number of inputs to one output, here one input to more number of outputs. Okay. Now we had seen that there is a strobe input available. So this strobe input can be useful in getting a higher order demultiplexer from a lower order demultiplexer, because within the strobe, by using a inverter the way we saw here in this example, we can get a 1 to 2 demultiplexer made. The basic 1 to 2 demultiplexer circuit, if you remember what we had done before. So this is the basic 1 to 2 demultiplexer circuit, right. So S0 is selecting S0 bar D and S0 D, one of these two inputs outputs is selected. So similar thing we can employ here, right, where this is the strobe input. So this particular combination is behaving, like a 1 to 2 demultiplexer, right. So when A is high, right, so then this is low, so this is the one that is getting selected, this block is getting selected, and when A is low, this is a active low, when A is low, so this one is getting selected, and when A is 1, this one is getting selected, right. So this is the corresponding equation, so you can follow this equation. So basically this A prime now becomes higher order the select line. Okay. So if this is S3 S2, S1 and S0, this becomes your S4, right. So, this is your 1 to 16 and this is 1 to 16, together with this one we are getting a 1 to 32 demultiplexer. Clear? So, this is basic IC 74154 equation which we have seen before. So, strobe, okay, we are converting to a select input. Okay. Now, we look at the other example. So, in this particular case IC 74155 is seen. So, IC 74155 we had seen before. In this we had noted that the strobe and data input are going to the same circuit over here. Okay. Same, this is basically your, if you consider this as input A and this is considered as input B. So, this is what you are getting here is A prime and B prime. So, basically whether you exchange A with B and B with A, there is no difference. Okay. What I mean, from the logic point of view, output over here, that cannot distinguish between A and B. Now, how does it help? So, because of the presence of the inversion over here, if you put strobe as data, and this data is strobe, then this inverter which is already present can be used to get a 1 to 8 demultiplexer, from this to 1 to 4 demultiplexer, and we do not need this external NOT gate as we had seen in this example, because the NOT gate is already present there. So, how we need to connect? We need to connect this 1C and 2C prime, just connect them as the select input, the additional select input, third select input, and the data is fed through this strobe. So, 1G and 2G we are connecting and we are feeding as data. Okay. So, if you look at this example and this example, so you make use of inherent presence of the NOT gate inverter in the case of IC 74155 because of the equivalence between these two. Now, this equivalence is useful, and we shall look into the next part of the discussion where we are using a decoder. So, this decoder is a circuit where the input bit pattern is identified by an appropriate logic and the output will be accordingly activated. So, if you want to decode say AB, that is a 2 bit that are presented. So, whether 0 and 1, A is 0 and B is 1, such a situation has arisen or not, okay, then how we find it out? We can find it out by simply a logic circuit like this. So, if you want to realize understand this, so A prime B, so with this we can figure it out. So, when A is 0 and B is 1, Y will become 1, otherwise it will remain 0. For other 3 possible cases of A and B, it will remain 0. So, to decode AB is equal to 1 1, we need this kind of circuit. So, if you want to have a circuit which can decode all 4 possible combinations, depending on our requirement, we can make use of one or the other. So, we can see inherently the 1 to 4 demultiplexer circuit that we had, it is following this particular output combinations. So, essentially if D is equal to 1, in each of these cases, this Y naught, Y1, Y2 and Y3, they are actually decoding the select inputs, isn't it? So, Y naught is S1 prime, S naught prime. So, it is equal to 1. So, in this case, if 0 0 is present, Y naught will be 1. So, if Y naught goes high, then we can say that A 0 0 has been presented, right, and for any other combinations it will be 0. So, if you want to decode say 1 0, right. So, D is high, and if we shall just look at Y2. Whenever Y2 goes high, we know that a 1 0 is present. So, this will be the corresponding circuit. So, that is what I said, that decoder and demultiplexer circuit is essentially same. So, just we have made a change in the orientation. So this select lines now becomes the input line, okay, input combinations that need to be decoded, and these are the corresponding output, and data input we are making high, okay. So if there is a strobe also we shall make active at that time. Basically it is between understanding a relationship between the select lines and the output in demultiplexer, which is converted to data or bit pattern to output in decoder. Okay. So the IC 74154, which is a 1 to 16 demultiplexer, if you want to make it work like a 4 to 16 decoder, so what we will need to do? We shall, as I just discussed, we shall make this as active, right? This is active low, so that's why it is connected to ground, and now it is just decoding the presence of the ABCD. So these are the data patterns. If 000 is present, so this is activated. If 0001 is present, this is activated, and so on and so forth. And if we want to make a instead of 4 to 16 decoder, say 5 to 32 decoder. So the way we had done in case of demultiplexer, we shall use the same kind of cascading using strobe and data, right. So this is the fifth input by which we can get a 5 to 32 decoder, okay. So this is similar to the Demark's concept. We had Demark's expansion concept that we had seen before. And finally, while we are talking about decoding and steering a output input from one to one of the many possible outputs, so this decoder can be useful, or this particular demultiplexer decoder can be useful in generating multiple outputs. So if you are in a looking for in a particular problem multiple outputs, so we can make use of a decoder or combination. Okay, so this decoders, this is an example given. So 3 to 8 decoder. So this Y0, Y1 to Y7, it is generating actually all the mean terms. So when A, B, C all are 0, this will be high, Y0 will be high, isn't it? And when ABC is 0, 0, 1, so Y1 will be high. So this is nothing but the corresponding mean terms that is getting generated. So if you want to generate a function, if you want to realize a function f1, which is a sum of mean terms 0, 4, 6, f2 sum of 0 and 5, and f3 sum of 1, 2, 3, 7, what we need to do? These outputs are there, okay, and we are just making appropriate OR of them. So 0, 4, 6, so this one Y0, this Y4 and Y6, right. And similarly 1, 2, 3, 7, this is Y1, Y2, Y3 and Y7, 0, 5, Y0 and Y5, and just we are summing them up with a OR gate, multi-input OR gate, and the job is done, okay. So this is one usefulness of another usefulness of decoder or demultiplexer circuit. So with this we conclude today's discussion. A demultiplexer steers the data input to one of the many output based on control inputs. With n control inputs, the data input can be steered to up to 2 to the power n outputs. Strobe or enable input of a demultiplexer chip need to be active for usual operation. Higher order demultiplexer can be obtained from lower order and vice versa by appropriate connection. A decoder decodes input bit pattern and activates the output when specific combination is present. Demultiplexer circuit can be made to act as a decoder. For example, 1 to 4 demultiplexer can act as a 2 to 4 decoder. And since decoder generates all mean terms, decoder or combination can generate multiple outputs by summing the mean terms that is generated out of the decoder. Thank you.